Welcome to the Stanley Street Social Podcast. We are here with Jonathan Shutler, the Senior Design Engineer here at Cannondale. Welcome to the podcast.
Thank you. Happy to be here.
So what's your background and how have you ended up here working for Cannondale in an engineering role?
Well, I'm certainly lucky to be here. My background started with getting a bachelor degree in mechanical engineering, staying on, getting my Master of Science degree in mechanical engineering, racing bikes that whole time, which is really one of the reasons I stayed on for a master's degree, waiting off until I get into a good job opportunity. And during that time, I was also a mechanic at a bike shop for about 7 years. Then I was lucky enough to pick up a position at Cannondale. I worked in our Connecticut office for a year. I moved to Taiwan, worked there for a few months to get some factory experience, and now I've lived in Freiburg, Germany for 6 years. And I've been working on some pretty exciting projects, which I've been really passionate about. The first one is the CAD 12, and after that, the SuperSix, and then the FSI, and then the SuperSix, and now the SuperSix EVO. So a lot of really fun projects.
So you've been in the thick of it all.
I've been through a lot of pressure and a lot of stress and a lot of high stress projects, I guess you can call them. Yeah.
How long have you been working with the company for?
I've been with the company now for a little over 7 years.
Wow.
Yeah.
So a good stint.
Yeah.
What do you think has changed most in the bike industry since you've been working? So I guess the last 7 years, what's been the major changes, do you think, in the industry as a whole?
Honestly, e-bikes are becoming the biggest change. Our office here in Freiburg focuses mostly on e-bikes. Most of the engineers here are working on new projects and a lot of new projects. This is where the industry is going with new customers, new riding experiences, new technologies. But if I wanted to focus it onto road bikes, which I'm mostly focusing on now, it would be aerodynamics.
Yeah.
Aerodynamics are right now the forefront of why a customer should buy a new bike. Weight really has kind of hit a standstill just with materials and manufacturing limitations, but aerodynamics are still opening new doors for us. And bringing about disc brakes, starting with the SuperSix, for example, has opened up new doors for us to make a much, much faster bike that's ever been seen before. And we've brought a lot of that technology into the new SuperSix EVO.
So 5 years down the track, where do you think bikes are going to go? What do you think is going to be the major focus area for Cannondale and all the other competitors?
I think lightweight's always going to be important. When new technologies come about, new trends, a lot of companies will try to get a product out as fast as they can, and that really limits a lot of the research that can go into that product, but they usually will tend to fine-tune themselves over time. So, I mean, disc brakes are still relatively new on the road. They're going to continue to evolve, and the weights are going to keep continuing to come down on those platforms. So I really feel like aerodynamics tied with more computational fluid dynamics, more FEA, a lot more numerical analysis with these are going to be really fine-tuning some super bikes.
Talk to us about your role with Cannondale. What do you do? What day-to-day? Working on new projects, what do you do? What is your role?
So my role at Cannondale as a senior design engineer is to take new concepts, new ideas, new research projects, and start delving these into new projects. So we get a project manager in here and he wants to have a new product down the road, and we piece together exactly what that bike should be, who the customer is. Then on the engineering side, we start working with what are the opportunities in front of us? How much time do we have to do it? So if I want to take the SuperSix, for example, we have the old bike, which was fantastic, and we want to look at what the new one might be. I start looking at the shopping cart of the new features that we want to put into this, what the weight's going to add on to that product, what can we do to reduce the weight of that. And that's essentially part of the product development process throughout the day. But if you really want to talk to my day-to-day here, I come in the morning and I work with Asia and I get all my emails, projects, work on everything up to date. Lunchtime, we always go ride bikes. So we go ride 1 to 2 hours if we have the time to do it. And then we come back into the office and the US office wakes up and then we have meetings with them all day. So we work essentially 24 hours a day with, not me specifically, but as a company, exactly, through Asia, through Europe, through the United States. So it's not just an 8-hour workday. That way we can continue to be very, very efficient.
Talk to us about the new SuperSix EVO that we rode today. What was the biggest challenges for you personally developing this product, and What did David Devine tell you at the start of the project? What were the biggest challenges that you faced?
So David Devine, the product manager here, he had a very strict weight limit on that project. As we all know, the previous generations of the EVOs were driven off of weight. They're still highly regarded as some of the lightest weight bikes that you can build up. I mean, that's where all the weight weenies go. They take those frames, those forks, they take the paint off of them, and they put the lightest components on to make these crazy, crazy builds. We didn't want to lose any of that. So the new SuperSix EVO, David gave a weight target that is the same or lighter than the last one, but we want you to make it faster, so less drag. Plus, we want to add more comfort. Plus, we want to make it through axles. Plus, we want internal cable routing. Go. And an internal seat post binder. So all these little features, we had to really go into the manufacturing of them. What can we do to remove weight from those? Let's look at the design. Can we take a different approach to pull weight out of them and still keep them functional?
And what was the biggest challenge in all of that?
Because
there sounds like a lot of challenges there.
Exactly.
The weight.
Fitting everything in there. The System 6 was a massive project because we integrated some of these features with that one. And the weight was a challenge. It's still regarded a lightweight aero bike, but we needed to figure out another approach to do that. So the internal seat post binder was one of my research projects I started at the beginning of this. We completely redid the manufacturing process. It is now a compression net molded part. So it's coming out of the mold complete.
Okay.
We've removed 100 minutes of man hours for machining, bonding, curing, bonding, second step overwrapping. It's now one complete part. So what that means is when we have a price for a frame, we can put some of that time back into materials for a reduction in weight as well. But the internal seat post binder for me was a personal achievement because we were able to get it to work. And the final weight for the internal binder is the exact same as an external seat post clamp on the previous generation EVO. But for me, the biggest challenge has always been the weight. It's, for me, 6 to 8 weeks I've spent in Asia just working on testing frames, testing stiffness, testing strength, countless iterations with laminates, a lot of stress with failures and solving problems constantly.
So the idea behind the internal seat post binder, was that all to do with aerodynamics?
That was due to weight primarily, but also due to comfort. When you remove the extra material above the top tube, like on some of the external binder bikes, it's about 3 centimeters of reinforcement above the top tube. And if you can get rid of that, you can get more deflection out of the seat post because it's anchored at a lower position.
Yeah, okay.
But it's also due to aerodynamics. So the way the seat post was designed, which may have been discussed by Dennis already, it was basically designed by the Di2 battery outwards. We know what the Di2 battery dimensions are. We know what the wall thickness is for testing required. We know the gap between the seat post and the frame. And then we know what the wall thickness has to be at the seat tube and seat tube binder junction to get the strength requirements. So we optimized all of these features to have a very slippery shape, which was developed by Nathan for a cross-section, but still have the strength and weight requirements required by product management and get the feature they need.
So how closely do you work with those two, Nathan and Dennis? Are you guys always talking? You must always be in communication.
Yeah, all the time. Yeah, so what happens earlier on in the project is I work on all the CAD data, so I have all the 3D models on my computer. I have to take the input from product management, what they want, what the industrial designers think it should be, what Nathan wants to see for tube cross-sections, and come up with a middle ground with all of this while taking consideration of weight, because I'm the structural engineer and I need to make this super lightweight bike. Yeah. And then I have to feed that back into Nathan, who can then talk to David about it as well, and Nathan will run CFD on it and tell me if it's okay or not, what do we need to change. But yeah, David's always in the loop as well because he needs to know what's happening to make sure that his project is following the right path. Yeah. Because you don't want to tell him at the end of the project what it actually came out. We want to make sure we get exactly what we need because he told us what will sell.
So once everything's been decided, everything's been signed off by everyone, what's the process of actually getting the bike to a finished product?
Oof. So once it's all signed off on everybody, we essentially look at the CAD model on my screen. It has all the components on it. I have to run through the entire project, how it's all going to work, how I calculated the weight, how we calculated the aerodynamic drag, make sure all the clearances are correct so we don't run into issues in manufacturing. And I take this complete project, all the 3D models, all the parts, all the 2D drawings, and I take it to our factory. I release it, and we go through even more design reviews to make sure they can sign off saying manufacturing is okay, we're good. But sometimes it even requires making prototype tools. Yep. Small, short investments. We test it real fast before we open up a very expensive full frame mold. And after we do that, the first frame comes out of the mold. We do stiffness testing. Then we'll do a quick strength test to see where we are. And then from there, you're always iterating laminates, whether making a new preform and a new mold, or we take the existing mold and put plies on the outside of it and retest that again. And that way we can kind of isolate where some of the problem areas might be with stiffness. Then after basically our time stops, we need to make a frame ready that's safe, that meets our strength requirements, stiffness requirements, and then we get one ready for riding. And also for assembly, we want to make sure we can fit all the components on there that product management wanted to put on the bike. Everything works okay, and then we start riding it to make sure the ride feels what we want. And a lot of times we'll loop back into laminate again if we didn't meet those requirements. So it's a very long, stressful project. I'm the middleman in all of this that has to coordinate it and make it work.
When you were talking about stress before, I now understand.
Yes. No, I've lost plenty of sleep on this project. And
you are the man at the center of it all.
Yeah. It's
I
deserve some sleep back someday.
How many, prototypes are pushed out before you get everything right? How many different... Man.
I mean, to be honest, the last frame, the final frame, I got here about 4 weeks ago. So as we're going into mass production, mass assembly with the final little details, whether maybe it's something that needed to be improved on a finished frame, I got that one here. So I've had probably 8 different complete, which I thought were ready to go frames, but because you have all these processes in place to find the issues, you may have to tweak something. Although sometimes they're just little minor details that people may never actually notice. We want to make sure the product's perfect.
Yeah. So
it's never just you have one ride frame, it's good, go. With lightweight projects like this, there's so much that can go wrong.
Yeah, I can imagine. Yeah. So for consumer, I'm a consumer, why would I buy this product, the SuperSix EVO? What for you stands out? What's the difference from every other bike on the market? Why would I buy this bike?
For me, it's speed. So, I mean, I've been an elite bike racer for the last 20 years. I like going fast. I'm training constantly. Most people, I think, know from experience trying to build an FTP as an athlete, it takes a lot of time. It's difficult to do. It's a lot of hard work. And for most people, actually everybody, there's a limit for what you were designed to do. It's genetic, right?
Of course, yeah.
So if you can't get any more watts, what else are you going to do? You have to look at your equipment and how you can make yourself even faster. So the SuperSix EVO is really the platform to do that because of the drag savings that you have from the previous version, but also all of the competitors that we've been testing. It's the same story with the System 6. It's very easy for somebody to spend money on the frame and get significantly faster, measurably faster.
Yeah.
We're not talking about just 1 second over a course of a 2-hour ride. It's a measurable watt gain.
Mm-hmm. Speaking to everyone before, I was saying I'm not a big bike fan. I've done a lot of riding, but bikes haven't really excited me. But today when we're riding this, I could actually feel the speed. It's ridiculous.
That's the most exciting thing about it. I train all the time on the road. And after a while, you've come to accept the speeds that you go. You get used to it.
Yeah.
But when you get on a new bike like this, you're achieving speeds that you never felt before, and you're not pushing any harder. So it's really kind of exciting. The early part of you, back in the days you first started riding, you kind of had that feeling I pedal the bike and it actually goes fast. It's a lot of fun. But now you're getting that feeling all over again because you're not anymore fit, but you have a bike that can go faster.
Yeah.
So for me personally, it's excitement starting all over again.
Yeah, exactly. Jonathan, thanks very much for joining us on the podcast.
Yeah,
and congratulations on making such a fantastic bike.
Thank you so much.
And catch up on the sleep.
I'll try my best. I'll start tonight.
Thank you.